All right, I want to take a few minutes to explain this law of conservation of mass lab. All right, so let's start by reading up here the introduction. So, according to the law of conservation of mass, mass is conserved in ordinary chemical reactions. This means that 100 grams of reactants should produce exactly 100 grams of products. And I want to stop there because that's the important part. So the law of conservation of mass is basically saying that the total mass of our reactants is always going to be equal to the total mass of the products. We're not going to lose any mass. We're not going to gain any mass. It's conserved. So that's what this whole lab is investigating. We're seeing, is this true? So what we've done here is we've carried out a chemical reaction, which is we've mixed baking soda with vinegar. And if anybody's done that at home or have seen that on a video or something like that, you know that there's some bubbling that takes place and fizzing. And a lot of times when you're in elementary school and you do you make a volcano, and to make the volcano erupt, you guys mix the vinegar with the baking soda and it kind of oozes out the top and so on and so forth. Anyways, so that's what we've done. All of these numbers in pink are the numbers that you need in case you were not here the day that we did the lab for whatever reason. So if you just read along, it tells you, and I've underlined just to help you guys pull out the important part of what that number is. So number 1, for example, it says measure the mass of the balloon by placing it on the scale. Record the mass. All right, do not zero the scale. So the mass of the balloon is 3.10 grams. All right, then 2, you're going to put the baking soda into the balloon. You're going to measure the baking soda and the balloon together. So mainly this whole experiment has taken place on the scale so that you could witness how the mass is working here with this reaction. So I'm not gonna go over every single one. I'm gonna skip down to the analysis part. So number 2 says calculate the total mass of the reactants and show your work. Now the reactants here are gonna be your baking soda and your vinegar. So you're gonna have to sorry, I'm like moving around a lot. I'm recording this on a phone. Y'all know I'm not too tech savvy. All right, trying to get my Sharpie. Okay. All right, so the reactants are your baking soda and vinegar. All right, to find the mass of the baking soda alone, we're going to take the mass of the balloon plus the baking soda. That was found in step 2. That was our 3.27 grams. All right, so I'm going to write that down here. 3.27 grams. And then to find the mass of the baking soda alone, I also need to know the mass of the balloon. So I'm going to subtract these two numbers. All right, so the mass of the balloon alone was 3.10 grams. All right, so if I take this number, this is the mass of the balloon and the baking soda, and I subtract the mass of the balloon, it's going to leave me with just the mass of the baking soda. Okay, so I kind of jumped ahead a little bit here to save us some time on this video. So we're still looking at this right now. All right, so the mass of the baking soda alone is 0.17 grams. All right, so now we're going to do the same thing with the vinegar, right? Because the reactants is not just the baking soda, but it is also the vinegar. So we need to find this mass plus this mass. So the mass of the vinegar plus the cylinder is going to be found in step 4. Step 4. All right, so we got the mass of the cylinder plus the vinegar. So 10.03 grams. Then we need to find the mass of the cylinder, which we measured as well, and that's going to be in step 3. So just the mass of the graduated cylinder was 6.86 grams. All right, so I've written that down as well. So just like this, we're going to do the same process, right? We're going to take this number and subtract it. And we get 3.17 grams. All right, so hopefully you all see that the mass of the cylinder plus the vinegar, right, is this number, and we take out the mass of the cylinder. We're left with just the mass of the vinegar now. So this is just the mass of baking soda, and this is just the mass of vinegar. All right, but we're not quite done with step 2 because we have to add 0.17 with 3.17 to get the total mass of our reactants. All right, so 3.17 plus 0.17 is going to give us, I'll do this up here. I'm going to move this. So this is 0.17 grams plus the mass of vinegar, which is 3.17 grams, equals 3.34 grams. All right, so that is the mass of our reactants for step 2, 3.34 grams. All right, now, number 3 on analysis. It says, calculate the mass of the products. Show your work. Now, the products is essentially everything that is produced from this reaction. So, by mixing the vinegar with baking soda, we're going to get some sodium acetate, we're going to get some water, we're going to get some carbon dioxide. And so we know that carbon dioxide is a gas, and that's one of the reasons why we see those little bubbles, and that's why it was important to keep the balloon on top of the graduated cylinder for the duration of the reaction so that we could trap all of that gas in there, and we could account for the mass of the gas as well. If we didn't have the balloon on there, all the gas would escape, and we would obviously have a hard time getting the mass of the gas included into our calculation here. So what we're going to do for the products is we're going to look at the mass after the reaction stops, and I'm going to pause again so we could save some time. Okay, so let's cover this up, and then we're going to look at the mass after the reaction stops. So that's 13.24 grams, and where I got that from was number 8 here. I'll record the mass after the reaction stops. So I got that from number 8. So that's the mass basically of the whole system after the reaction has taken place. All right, so that also is going to include the mass of the balloon and the mass of the cylinder, which we know that we don't want. We're trying to get rid of those masses so that we could look at just the mass of the products, so we could compare that to the mass of the reactants. All right, so what we're going to do is we're going to, similar to step, I'll just get rid of both of those, similar to question number 2 up here, we're going to do some subtraction. So we're going to take the mass of the balloon, which was 3.10 grams. Again, I got that from step 1 here, mass of the balloon. And then we're going to subtract that, and then we're also going to subtract the mass of the cylinder, which was 6.86 grams, which I got from step number 3, just the mass of the graduated cylinder, 6.86 grams. All right, so 13.24 minus 3.10 minus 6.86 is going to give us 3.28. All right, so now this is the total mass of products. All right, so now in the analysis questions following number 2 and number 3 is going to ask you to compare. It's going to ask you some follow-up questions basically about what these numbers are telling us. So our total mass of the products is 3.28 grams. Remember, our total mass for the reactants was 3.34 grams. I'll just back it up so you guys can see the whole thing at once. So we're comparing this number to this number down here. So it's pretty close. 3.34 grams is very close to 3.28 grams. So one of the questions is, if you see some discrepancy in the numbers, what do you think could have happened there? And so a number of things could have happened. There could have been error when you were measuring on the scale. For example, I don't know, I took these numbers from one of the groups in my second period class, so maybe they had some kind of issue when they were using the scale. That could have accounted for it. Maybe their balloon wasn't completely sealed around the graduated cylinder, and a little bit of gas could have escaped while the reaction was taking place. But I'd say for the most part, we're really, really close to the numbers being equal. So hopefully this helps you guys out. And again, this is just showing conservation of mass. So the mass of the reactants should be equal to the total mass of the products.